Hello everyone, welcome to my YouTube channel. Today we are going to solve Leetcode 297, serialize and deserialize the binary tree. So it is marked as the Leetcode hard. It is a decent level question. So the question state that we have a given a binary tree. We have to convert it in a string format and we have to write another function for the first function we have to write a serialize function in which we have to convert a binary tree into string format, and in another function the serialized string that we have converted are given and we have to deserialize it, means we have to convert it into the binary tree again. So this is the overall process. So here are the given the definition of the serialization, means it is the process of converting the data structure or object into the sequence of bits so that it can be stored in a file or a memory buffer or transmitted across a network connection. So like it is the process in which like we have given object and the files, so we cannot directly store into the our databases, so we have to serialize it, we have to convert in the bit comma bits so that we can store it into the our databases. And we have our deserialize function in which we again generate that object from the given bits that are stored in the database. So we have to design an algorithm to serialize and deserialize the binary tree. So there are no restriction how you serialize and deserialize the algorithm should work. Means we can write our own algorithm for same procedure. In the serialize, we have to convert in a string, and deserialize the string that we have converted are given to us, and we have to again generate the root of the given tree. So this is our question. So this is the tree. How we will proceed? This is the tree. First we have to understand that if there are no nodes or marked, means for the leaf node, its left is null and the right is null. Ah, it's a both child for this node, its left is null, right is null. For 5 left is null, right is null. So first major thing we have to keep in mind that if the node does not have child, means it has a child of null values. So we have to keep that in mind. So we have to generate a string from this for serialize function. So how can we generate a string from this? We can do a label order traversal. Like we go label by label and we store our values. So we go to the one. So how do we do our label order traversal? So we do label order traversal by the queue. So we go to the root. Root is not equals to null. So we will add in one and we will create a string buffer. It is our queue and it is our string. Our string is one. So always keep in mind, always add comma with it. Like how we are going to differentiate this node ends and this node starts. If there are 10, 1 and 0, then it is very confusing. Is it value of having 10 or 1 and 0 two nodes? So always separate our nodes with the comma. So we add 1 and we'll mark comma. Then it's a left child and right child, add into the queue, add into the queue. One is processed, then we go to the two. Uh, for two, we add this into the string, add comma. Then two has a left child, right child null. So we will add null into our uh, queue. We will add null into our queue and left child, right child null. Then we process two, then we go to the three. So we will add 3 with comma, and we will add its left child and right child. What is left child? Left child is 4 and the right child is 5. So then we go to the null. We go to the null if it is null. So one thing keep in mind, if it is null, it does not have any left child or right child. But we have to add this null into our string so that we can identify later that its child is null, like whose child is null. So we will add null here and with comma. Then again we go to the n. We fold it from here. We add n. Then we go to the 4. We go to the 4. 4 is the node, means it is not equal to null. Then we add 4 and comma. We add its left child and right child. We go to the 5 with comma. Then we add left child and right child. Then we go to this null, means this n. Then we go to the this n. Then we go to the this n. Then we go to the this n. So this is our serialized string. So this is our serialization. One process is done for the serialization. We get a string like we can here understand like one is a node. Then we go to the two means 2 and 3 are the child of the one. Then we go to the two. You can see after two what is our next two node? Next two node is null null. Means these two nulls are the child of two. Then next two are the child of three. Then it is null, it does not have any child, then we go to the 4. The next two are the child of 4. Next two are the child of 5. So basically we can understand, we mark this in a fashion that we can easily understand that this is the child or not. And we will separate it by the comma. So like it is our serialized. One part is done for deserialization purpose, like how we are going to solve, like same thing is going to be solved here. Like if let me write it again. Uh, Let me erase this one. This is our cube. In this same, we are going to problem. Like we will reverse this problem. Same. So we start from this. Like if our first value, like it is our string. So what we are going to do? We will split it. We will split it with our commas. We will split it with our commas. So our new, like ARR will be like our array of 1, 2, 3, and 4, 5, and 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 this is our array. Now we split it with comma. You can like don't take serious that we added comma. So it is just for a notation purpose. We added like split it by the comma. Then we start from the index value. Like index, our index is like we start from our index value. We make a variable index. Initially value is 0. Index is used to iterate on this array. So like if the first value is null, null means n. If the first value is n, means its root is null. If the root is null, we cannot go to the further, then we will return null. Otherwise, this is our one. So we add it into the our queue and make a Like we added into the our queue. Sorry. First we make a tree node. Like we make a tree node, then we added into the queue. Then we will process this until our queue is not empty. First we go to the one, we fold one from this. Uh, then we will move our index to one. Like first we make a tree, we will move our index to one. We are at index one, like we are at two. Is two equals to null? If two is equals to null, we will add this value on the left side. Like for one, we will add this value null. But it is not null, it is true. Then we create a tree node. We will create a tree node and move index. Now index is 2 and we create a tree node with the value 2. Then add it into the our queue and make it the left child. For the left child, we will make it and add to the parent. Then we are at value 3. Like at the serialization time, we remember that for a particular node, there are two values. Either there will be the values, otherwise there will be the null in the string. So we have to check the both. This is the left side, this is the right side. So we added to the next value is for 3. So for 3, we added 3. We make a tree node 3. We added it into 3 and we will connect it to the 1 and we move our index to 3. Then like left child is done, right child is done, one is pop, then we pop another value like we pop default 2 from the queue. So 2, 2 next node like for index 3, value is n, means it is left side is null. So left side is added to null, means pointed to 4. Right side is also null, so right side is also added to null. So this is added to null, this is added to null, and then we go to the further. Like this what is done, we process for the 3. So for 3 our index is here. For 3 left child is 4. So we make a left child and added it 4. Now our index is 5. And right child is 5. So 4 is linked with 3. 5 is linked with 3. Then we go to the 4. 4 means the value is null. Value is null. So left child is null. Right child is null. And for 5, left child is null, right child is null. So simply we get the deserialized binary tree. We get the binary tree. So this is the overall procedure we are going to solve this problem. So it will be better understand by the code. Let's see the code, how the things are working. So like this is the this is our code class. We have to complete two function like function serialize and function deserialize. In the serialize function, we have to make the string, we have to return a string. And in deserialize, we have to return the root of the tree. So let's see how we are going to solve this problem. Uh, so this is our code. So if our root is null, we are given the root of the tree. So if our root is null, then we will return a simple string n. We are added n for the null value. So if our root is null, we simply return n. Otherwise, we create a string buffer to store the value and a queue for label of the traversal. First, we added the roots to start our label order traversal. Simply label order traversal code like while queue is not empty. We poured the queue value and process the left side and right side. If our node is null, so we added null and comma. Otherwise, means it is having a value, then we added node dot value plus. It's from plus with the comma and both left side and right side. So in general order level order traversal, we check that the left side value is null or not, right side value is null or not. If it is not null, then we added it to But in this case, we can see that we also need null for this. So if the value is null, we will add n. So we will directly can add into the our queue. Then further we process this. Then this is the simple code we will get. After that, we will return that sv dot. We will return a string. Like we have a string builder. So sv dot to string is a function to return a string. So this is very simple code for the serialization. Now deserialization is also very easy. Like if our given string, like our given string is n equals to n, then we will return null means it is null. Only one node it is null. Otherwise, we create a queue for the label order traversal and we create an array of string by the data dot split. Remember, I told you that we will separate this string. We will separate the node by the comma. So we split our string into the array. We start from index 0. So what we did to initiate like a traversal in the queue, label order traversal in the queue, we first added that tree node. Like we created a tree node, we added into the queue. So how we added the string value to the integer dot parseInt and array index plus plus like first value. We use first value in the zero value, then we will move to the index one. And we will do this until our queue is not empty. So first we pull from the queue, then we will check if index is less than array dot length. It does not. It is obvious that the length should not exceed. Like it is not equal to the length, and array of index is not equal to null. Means if like you can see here, we do not have to add the null values because in the code definition, left child and right child are default to set null. We do not need to set null until we do not have the authentic node. So we create a left node. If it is not null, then we create a left node integer dot parseInt and we added it to the left child and also added into the queue for further processing and move index one step ahead. Then again check array dot it does not exceed the array limit and it is not equals to null. Then we create a tree node and like parsing convert it to the integer, connect to the our tree and added into the queue. Then index plus plus. This simple code. After that, we will return our root. So very simple approach to solve this problem. What is the time complexity? Like we are doing label order traversal. We are maximum visiting a node into the ones. So we are visiting node one. So we go often. It's the time complexity of this. What is the like space complexity? Big O of one is the space complexity. Same is for the deserialize. Same is for the deserialize. We are using like here we can say we are using two n, but overall big O of n is the space and time complexity for both the functions. So that's all for this. It is very like decent level question. It is not that tough, but it is a very good question. So thank you for this video. Thank you for watching this video and bye.